Hey guys, welcome back to Genius Learning. Here we take a look at another implicit differentiation problem. And so to take the derivative of this, I want to make sure I have no exponents, which is fine. And just want to make sure I remember what the derivative of arctan is. So if I have arctan of u, for example, I'm going to have the derivative of u prime, which is this inside, over 1 plus u as my derivative. Okay, so let's start with 5. That's going to be 0, so the derivative of a constant is going to be 0. And then plus, here we're going to have a product rule. Okay, so I'm going to write here f times g, which is f as the x, times g, which is the arctan of y. So f prime g plus f g prime. So let's start with the f, which is x. So f prime is going to be 1, and then the g part comes along. So we're going to have arctangent of y. Okay, and we haven't taken the derivative of y yet, so this is just, it came along here with the g. So now we have plus, the f comes along, which is x, and then g prime means that now we take the derivative of a y. Okay, so I'm going to put parentheses. So the derivative of the inside here is going to be 1. So we write 1 on top, right? And then over 1 plus u squared, which is just just y squared. And then we took the derivative of y, so we're going to write dy dx next to that term. So I'm going to circle it. Okay, and then I wrote this in a bad place, but I'll go down here. So equals, right? This follows here. Equals, the derivative of this is just going to be 2, and the derivative of secant is going to be plus secant x tangent x. Okay, so let's write that a little bit more clear on the next line. We have this term that was 0. We did the product rule here because we have an x and a y together. So this term does not get a dy dx because we took the derivative of f prime, and then g just came along. Plus, now this came along, and then the derivative of g was this, and dy dx came along, right? Equals, the derivative of 2x is just 2, and the derivative of secant is secant tangent. Okay, so let's try to isolate the dy dx, and we're going to write it on one side. So dy dx, and this term is attached to all this. So let's write x over, I'm going to slide that up here, 1 plus y squared. Okay, that's this entire term here. And now I want this on the other side of the equation. Okay, so I'm going to write equals, and I'll write these two first. So I'll write 2 plus secant x tangent of x, and now I want this also on the other side of the equation. So I'm going to write, it's a positive here, it's going to be a minus on the other side. So minus arc tangent of y. All right, and so all we need to do now is get rid of this term here. So we could do it one of two ways, right? We can just divide this entire thing down here, but then we're gonna have to flip up the fraction. And so I feel like an easier way would be just to multiply both sides by its reciprocal. So if I multiply by 1 plus y squared over x, right, these two are reciprocals, and so I have to multiply this side here by 1 plus y2 over x. All right, so this side here cancels, and we're left with dy dx. And now this side, I'm just going to leave that how it is. So I'm going to say 1 plus y squared over x. And then inside the brackets, I'm going to write all this term here that was already there. So that's 2 plus secant x tangent x minus arctan of y. All right, and so then we can leave it like that because we got our dy dx. Okay, and there you go.